Hello, these are essential exercises from Openstax Calculus Volume 1. They're exercises, but I'm picking out a few which I think are essential. So this is number 59. I think this is from chapter 4, and it's the section on linear approximations. What we're going to do is we're asked to find a linear approximation to the expression rounded to the hundredths place, but by deciding on the appropriate f of x and a and evaluating the linearization L of x equals f of a plus f prime of a times x minus a. All right, now the thing is that we're going to use a linear approximation to find 15.99 to the 1/4 power. The idea here is that 15.99 is very close to 16, and we can easily evaluate 16 to the 1/4 power, which is 2. And so what we're going to do here is we're going to let f of x equals x to the 1/4 power, and we're going to let a equal 16. So a should be a number that 15.99 is close to. And then if I put that number a, which is 16, into the function, I get 16 to the 1/4, which is 2. So to use this formula, I also need to find the derivative. So I'll do that using the power rule. And I could see possibly a issue of trying to understand how to evaluate f prime of 16. So we'll talk about that. Okay, so let's see. F of 16, which is f of a, is 16 to the 1/4 power. And what does that mean? That means the 4th root. If you want to write that down, it's the number, which is 2, such that 2 to the 4 is 16. And then f prime of 16 is 1/4, 2 to the 3/4. All right, so now what does that mean, 2 to the 3/4? So one way to look at this is that you take the, oh, sorry, I did that wrong. Over here, it's 16 to the 3/4. 1/4, 16 to 3/4. Okay, so you take the 4th root of 16, take the 4th root of 16, and then you raise that to the 3rd power. So you have 1/4, and then the 4th root of 16 is 2, and so that's going to give 1/4 times 8, which is 32. So I suppose maybe as an aside, I can write down that if you have x to the m over n, that's the same thing as the nth root of x raised to the m power. Now it's also the same as saying x to the m and then finding the nth root. Those are all equivalent. And the reason I took the 4th root first and then raised to the 3rd power is that I thought that would be easier. So if I do 16 to the 3rd power, well, I suppose I'd have to think, what is that going to be? Anyways, I think it's 2048 maybe, but anyway, it's harder if I do 6 to the 3rd power than take the 4th root. It's easier to take the 4th root and then raise that to the 3rd power. No, actually, so maybe it's, anyway, sorry. So the 16 to the 3rd power, I think, is, it should be 256, yeah. So you could do 16 to the 3rd power is 256, and then take the 4th root. You can do it that way and get 8. Okay, so that's just something else there. But anyway, so here we go. We have L of x equals f of a, which is 2, plus f prime of x, or f prime of a, which is 1 over 32. And then we have x minus 16. Okay, now what we're supposed to do is approximate this 15.99 to the 1/4. And what we're saying is that this is approximately L of 15.99. Okay, so this is why we have a linear approximation, is that if I put in x equals 16, I actually get 2. So under the approximation, if the approximation is done around a equals 16, and if I put in for x into L of x, if I put in 16, I get 2. If I get 15.99, if I put 15.99 in, I get something close to the 16 to the 1/4. And so this is going to equal 2 plus 1 over 32, 15.99 minus 16. And you can sort of see why I don't simplify this L of x any more than it's shown there, is because I want to find the difference between 15.99 and 16, which in later sections that would be called dx. All right, and then this whole piece right here, this 1 over 32 times all of that would be dy. It's so what we have is we have 2 plus our little bit of a change. That little bit of change in y is dy. So 15.99 minus 16 is 0.01. And then, I mean, there is an issue of if am I going to take out a calculator or not? And my answer is no, I don't think I am, because I don't really want to use a calculator. So I'm going to leave it like that, and I'm not even going to get a common denominator or anything. So it says, I think it says I'll run to the hundredths place. That's if I have a calculator. If I have a calculator, I'd put it 15.9 to the 1/4. But I'm not going to do that there. And you can do that, which maybe I should at some point. But I try not to use calculators in my class. Okay, let's try to do this next one here, where I have. I'm going to use f of x equals sine x. Of course, that's an easy one to find the derivative. And then I'm going to have a equals pi. Well, 3.14, as you know, is close to pi. It's an approximation for pi. So f prime of x is simply cosine x. It's easy enough. And then I have f prime of a is f prime of pi. Well, I'm sorry, I don't want to do f prime yet. I'll do that in a moment. F of a is sine of pi. Well, sine of pi is equal to 0. And I suppose I can draw a little picture of the unit circle to justify my statement there. Cosine pi is negative 1. Okay, let's just waste some time here and draw a unit circle. All right. I mean, a waste of time, maybe all of this is. It's just sort of fun, in my opinion, like a hobby. But of course, there are people that use this for important things. Okay. So pi, we have negative 1, 0 on the unit circle, and the x-coordinate corresponds to cosine, and the y-coordinate on the unit circle corresponds to sine. So sine of pi is 0, cosine pi is negative 1. And then we go ahead and plug into that our good old formula, which is L of x equals f of a plus f prime of a times x minus a. So therefore L of x is equal to 0 plus negative 1, x minus pi. So, all right, now what's the idea here is, well, what we're going to do is we're going to say that sine of 3.14 is approximately equal to L of 3.14, and that's going to be negative 3.14 minus pi, which is the same thing as if you distribute the negative, pi minus 3.14. So that's sort of, that's interesting. The problem is if you don't have we would need an approximation for pi. A longer approximation would be, we have 3.14, but at least 1592653. Possibly. What is pi equal to? The last part is the zip code of I believe Laguna Beach, California. No, Laguna Hills, California. That's what someone told me. And there was once in my lifetime Pi Day, which is March 14, and it was 2015. And then there was 9:26 a.m. But anyway, the 92653 is I believe is the zip code for Laguna Hills, California, and that's how I remember that part. But I should maybe double check. If that's wrong, do I need to do a whole video? I mean, the thing is that I just used the calculator to do this, so why didn't I use the calculator for sine of 3.14? What is sine of 3.14? All right, what I'm doing here is using my iPhone and using Siri to get this answer here. Oh no, it's coming from Wolfram Alpha. So Siri is accessing Wolfram Alpha, and okay, so mine would be exact if I just if I stop putting the 3 there. But it's true what I said, is I believe that it is a 3. Okay, so anyway, it's a pretty good approximation, like spot on, right? So that was interesting. So I mean, doing this method of linear approximation is spot on. If you have an approximation for pi, that's not included in this lesson of how do you how to get an approximation for pi. Okay, so that's this. There's all more stuff to study on approximations. Approximations are very important because I believe that's what the calculator is doing in Wolfram Alpha. Is I don't think Wolfram Alpha had that information sitting there waiting for me to. I think what they did is that they had an algorithm. You put an input and then it runs through a function. According to the authors in Openstax, the approximation the calculators use is not a linear approximation. The linear approximation is, as you can see, the linear approximation is let me highlight those linear approximation functions. Those linear approximation functions are polynomials, but they're lines, they're first degree polynomials. But we can also make second degree polynomials and third degree polynomials, and those are more accurate. Those are closer to the true value of the function evaluated a number if you had second degree or third or fourth degree polynomials. All right, so that finishes this piece. This is from Openstax Calculus Volume 1. That is open source and it's legitimate from Openstax, and that's, I believe, in close affiliation with Rice University, and so that's the real deal, and it's available to all of us, open source, free of charge, no money making here. All right, take care. Goodbye.